some harder question of sine formula. So first of all, according to the graph, there are some information, and the question is asking us to find BC, this one. And first of all, we need to draw a straight line which is parallel to DA. So if you like this, it can form a parallelogram. Okay, so I say this one is CE. Okay, so the first step is, once I find C parallel line CE, which is parallel to DA, I can find the angle of this one. This is the first step, and then I can find, this is the second step, which is equal to 14, and we know that the first step, this is 6, and finally this is the fourth step, which is 135 degrees, and this one is 15 degrees. So we can have a pair of angle and line. Okay, so in presentation like this, for the first part, I need to find the length of CE, okay, for part A. So what we need to write is, we add CE such that CE is parallel to DA, and DAEC is a parallelogram. Okay, after that we can write down is AE, which is equal to DC, equal to 14, and the reason is opposite side of parallelogram. Okay, and then so BE is equal to AB minus AE, which is equal to 20 minus 14 equal to 6. So this is the first one, and then for the second one, so the second angle is angle ECD is equal to angle DAE, which is equal to 135 degrees, and the reason is opposite angles of parallelogram. Okay, this is 135, and therefore this one is 15. This is the second step. So angle BCE is equal to angle DCB minus angle DCE, which is equal to 150 degrees minus 135 degrees, which is equal to 15. So this is the second part. What now we have a pair of it, which is angle ECB and EB. We have a pair of it, so we can find BC. So as we know, for the first step is BC over sine angle CEB, which is equal to, our pairs is BE over sine angle ECB, and therefore BC is equal over sine 135 degrees, okay, because BE is 135 degrees, and then equal to B6 over sine 115 degrees, and you will get BC is equal to 16.3923 cm. So I will save it in calculator, and you give the answer in 3 significant figures, so which is 16.4 cm. So 3 SF. This is the first part, and then for second part is find the length of AD. So this one, so that means we need to find CE, and which is according to the properties of parallelogram, you can find AD. So for the first part is, we need to find CE first, and then you can find AD. So for part B, I write here, so find CE first. As we know, in this triangle we have a pair of angles and corresponding angles and lines, so we can find this angle first, and then we have another pair. So angle CBE, which is equal to 180, minus angle CEB minus angle EBC, and the reason is angle sum of triangle. the first one, and which is equal to 180 degrees minus 135 degrees and minus 15 degrees, and you will get 30. So therefore you will get this one is 30 degrees, and you can find CE. So applying the sine formula, which is sine angle CBE equal to BE over sine angle ECB. So you substitute the value of BE and the angles, you can get this one, and finally you will get CE is equal to 11.5911 cm. And once you finish finding CE, and you can get AD because of the opposite side of the parallelogram. So what you need to write is, so AD is equal to CE equal to 11.6 cm, and the reason is opposite side of parallelogram. So that's the end of question number 1. And then for question number 2 is a little bit long. So first of all, try to find length of BC and CD. So length of BC and CD here. So what we need to know is you still need to draw at one line so that you make a parallelogram in it, just similar to the previous question. So I will write down CE here. Okay. So first part is add CE such that CE is parallel to AD and DAEC is a parallelogram. So now what we need to find is for the first angle, which should be for the length here. This one is the first length, which is equal to 6, and for the second part, we have a pair of it. Okay, so another part we can find this second angle, which is 99 degrees, and then we can find the length of EB, and finally you can get the angle in the 4th step and the 5th step. Okay, so for the first one, first step, which is CE, is equal to 6, and the reason is opposite side of parallelogram. Okay, and then for the second step is angle CEB is equal to angle DAE, which is equal to 99 degrees, and the reason is corresponding angles of congruent triangle. Sorry, corresponding angles of parallel line DA parallel to CE. Second step, and therefore we have the first step is we can have angle ECB, which is equal to 180 minus angle CEB, and angle CBE, which is equal to 180 degrees minus 99 and minus 50. So this is the third step. So change a little bit. This is the third one. Okay, and then once you finish, you get is 31 degrees, and you can find the value of BC because we have a pair of line and angles. So CE over sine angle CBE, which is equal to BC over sine angle CEB, and equal to BE over sine ECB. So you substitute the number of it, so sine over sine 50 degrees and equal to BC over sine 99 degrees and equal to BE equal to sine 31 degrees. So you can solve the value by each pair. Okay, so you can get his BC is equal to 7.736 cm, which is 7.74 in 3 significant figures. And then BE is 4.034 cm. So we have finished BC, okay, and try to find CE, and then we need to find BE is 4 point something, right? So we need to find AE, okay? This is a 4 step, 5 step, and 6 step. So the 6th step is AE is equal to AB minus BE, which is equal to 5.96599. So CD equal to AE equal to 5.97, and the reason is opposite side of parallelogram. Okay. So for part B, find the area of ABCD. So in this time ABCD, it consists of 2 items. You need to find the height of the parallelogram, okay? So like this one, that means H. Okay, so after that, you need to find the area of parallelogram and the area of triangle. And pay attention is the height of the parallelogram and the triangle are the same because they share the same height here. Okay, so what you need to write is, I try to let AF be the height of parallelogram. So first step is angle DAF is equal to 99 degrees minus 90 degrees. So this one will become 9 degrees. So I try to draw a right angle triangle here so that you can imagine it easily. So it will become DF and A. And this one is 6 and this one is 9 degrees. So in triangle DAF, which is we can use the cosine function. Cosine 9 degrees is equal to AF over DA. So AF is equal to 6 cosine 9 degrees. So this is the height. Okay, so we can find the area of ABCD should be, the first one is the area of parallelogram DAEC plus the triangle of CEB, the second area. So the first one and the second one, and that means is the height is this one, 6 cosine 9 degrees times the base is AE, and then plus the height, and then times the base of BE this time, so which is equal to 47.3 cm square. So it's a little bit long for question number 2, okay? So for question number 3, in the figure ABC is a straight line. So in the data is mentioned in the graph. So first of that is find ADB. So this one is our target. So what we need to find is the first step is this one is BDC. This is our first step. Okay, and then for the second step is need to find the large angle. And the large one, the second one minus the first one, we can get the answer. So for part A, how can I find the first one? It's not difficult because is DB equal to DC given. So angle DBC is equal to angle DCB, which is equal to 61 degrees. Base angles are isosceles triangle. So this one becomes 61 degrees. Okay. So and then for the second one, so in triangle BDC, we can use the angle sum of triangle, which is equal to 180 degrees minus 2 times angle DCB. So it's angle sum of triangle, and you will get is 58 degrees. So second step, this one is 58 degrees. And the third step, so I consider a large triangle ADC. So our target is try to find a angle ADC. So it's easy because of the angle sum of triangle. ADC is equal to 180 degrees minus this one, A, and minus this one, C. So you will get is 180 degrees minus 55 degrees minus 61 degrees, and you will get is 64 degrees. Okay, so the second step, I can find the value. This one is 64. So that means A dot boy is, so angle ADB is equal to angle ADC minus angle BDC, which is equal to 64 degrees minus 58 degrees equal to 6 degrees. So we finished the part A. And for part B, find the length of AB, this one. And need to find a pair of angle and straight line. Okay, so this one is 6 degrees. And then therefore first step, I can find the angle DBA. And we will get a pair of angle and line. So it's easy to find AB. So to present it is in triangle A dot boy, which is the angle ABD is equal to 180 minus, angle DBA, and then minus angle ADB, which is equal to 180 minus 6 degrees, and you will get is 119 degrees. So we finished the first step, and for second step, we apply the sine formula. So AD is over sine ABD, which is equal to AB over sine ADB. So it's equal to 16 over sine 119 degrees equal to AB over sine 6 degrees. So you will get is AB is equal to 1.91 cm. So 3 significant figures. Okay, that's the end of question number 3. So in question number 4, so in this time we get the set is 30 degrees and y, the ratio of two sides, one is y set. Okay, y set is here. But I kept small letters x, and xy is small letter z. Okay, with 2 to 3. So I'll try to express in here is y set. That means x over z is equal to 2 over 3. So how can I find the angle x? So first step, we apply the sine formula first. Which should be the z, letter z, small letter z over sine 30 degree. Okay, which is capital letter Z. Okay, I'll write them one more step. Which is equal to x, small letter x, over sine capital letter X. Okay, our target is find the value of capital letter X. So, and then we know that is x over z. We arrange some order, sine x, which is equal to x over z multiplied by sine z. Okay, so and that means we know that x over z is equal to 2 over 3. So that means 2 over 3, and sine x we change to sine 30 degree, and you will get sine x. And then this is not difficult to do it by calculator. You will get is the x, angle x will become 19.4 something, and which is equal to 19.5 degrees for three significant figures. And for part B, find xz, that means xz, that means the small letter y, and the value of these two ratios, that means xz is the small letter y, and xy is the small letter z. Okay, so first of all, we need to calculate the angle y first. So angle y is equal to 180 degrees minus angle z and angle x, and which is equal to 130 something. And then we can apply the pair which is y to the angle y, and then is z to angle z. So I can write down xy over sine z, okay, because xy is capital letter, small letter z, and xz over sine y, okay. So and then we change the subject to xy over xz. Okay, sorry, xz for in the numerator. So it should be xz over xy is equal to sine y over sine z. And you do it by calculator is you input the angle like this. Over sine 30 degrees. And you will get the ratio becomes 1.52, 3 significant figures. Okay, for the last question of worksheet 2 is now AB is 30 degrees and then AB is 20 cm long. So Kelvin claims that the minimum length, okay, pay attention of this one, minimum length. So what situation will be AC becomes a minimum? So the minimum length is 10 cm. So do you agree? So part A, I try to show you in graph. It will be like this. So let this one be A and B. Okay, and then we have a horizontal line here. So we call it, this angle B is 30 degrees and AB is 20 cm. So when will be AC is the foot here. So we have many options. For example, here, first one, second one, third one, and fourth one. Okay, so we can C1, C2, C3, C4. So when will be AC be the shortest is once is AC perpendicular to BC, then the length of AC should be shortest. Okay, therefore, refer to the graph is the minimum length of AC we can conclude should be AC is perpendicular to BC. So that means we can consider a right angle triangle. So like this. Okay, so A here, C here, and B here. So it is easy to find the value of AC. So in triangle ABC, we can get sine 30 degrees is equal to AC over AB. And therefore AC is equal to 20 sine 30 degrees, which is equal to 10 cm. So we agree what Kelvin said. Okay, for second one by B, so we know that find the range of length of AC such that two triangles can be formed. What does it mean is, first of all, AC must be greater than 10 cm, right? And then, as we know that if AB is must be the longest side, so that AC can have two types of triangle. Okay, the first type can be like this. I try to draw it in red color. So we like this, the first one, and the second one is like this. Okay. So if it's longer than 20, that means the maximum size we have only one triangle only. And AB is the longer side. Okay, so 10 is between AC and AB. Okay, so it's 20.